Hey everyone, welcome and thank you for joining this event. My name is Alex and I have the pleasure to be your host for this event. Java on Azure is a very dear topic to me, not only because I'm a Java developer myself, but because it's also related to the open source projects supported by Microsoft. Speaking about open source projects, did you know that Microsoft maintains an OpenJDK build? I bet not all of you are familiar with that fact, as well as the number of tools and plugins in VS Code, Azure, and GitHub created specifically for Java developers. We do have a page that kind of provides a tons of information about all that stuff and how to get started with Java on Azure. And by all means, I do encourage you to go there and check it out. But what we wanted to do with this event is to show you some of the most interesting aspects and scenarios to get you started. Now, I know that you're not here for the PowerPoint presentations, and we are not going to do this, but allow me just to share two slides to set up the context for what's to come. Now, on the first slide, you'll see a summary of the different tools and plugins that we have to support your coding and building efforts. On the second slide is the different options that we provide with Azure to deploy and run your code. At the top part, you'll see the different application servers and frameworks that we support, but I think it's the middle part that's really most interesting. Now, you can run everything on virtual machines if you want to have like a full control of what you're doing. It's a great place to kind of start. If you are using containers, because we all love containers, right? It's easy way to ship our code. You can choose from the Azure Kubernetes Service or Red Hat OpenShift, which is fully supported on top of Azure. But I think the most interesting part is the platform as a service options that we provide. From my side, we have the Azure Container Apps, where you can still deploy containers, but without the complexity of managing deployment descriptors or managing the Kubernetes cluster yourself. In the middle part is the Azure App Service, where you can deploy your code or jar files directly. It's a great option as well. And finally is the Azure Spring Apps, which is a totally separated service for running and managing your Spring applications. Now, of course, any application would usually use some data or communicate with some database. So I just listed the options that we have here as well. So Postgre, MySQL, fully supported on Azure. For any NoSQL needs, you can go to Cosmos DB. And of course, Redis Cache is fully supported again for Azure. It's a popular caching choice for yourself. Now, with that already covered, let me just quickly jump and do an overview of the sessions that are coming. We'll start with Brian, who will be talking about the Azure Container Apps and how we can deploy there. It's a great start for any development that you're doing. Then we'll move to the session that was prepared by Steve. He'll be talking about the Azure Spring Apps, and he will also cover what are the differences between the Azure Container Apps and Spring Apps and which is the best one to use for different scenarios. Then Brian will join us again. He'll be talking about the GitHub actions that you can use to deploy the applications, and he will be deploying to the Azure App Service. Now, in this case, he will be deploying code and a jar file, not a container, so it's a good thing to see as well. Then we'll switch gears and move to something different. We'll have Bobur, who will be talking about real-time event-driven Java solutions using Azure Functions. So it's your serverless approach using Java, also great content. And finally, Ramaya will be joining us, and she'll be kind of covering the Azure Functions with another popular open source project called Kafka. That's all we kind of prepped up for you. During all the sessions, feel free to post your questions and comments. We'll be around to answer them all. And with that, let's give it up for our first presenter, Brian.
Hello, everybody. My name is Brian Benz. I'm a cloud advocate at Microsoft, and I'm here today to talk about enabling reliable code delivery for the cloud with container apps. This is a presentation that is going to be 100% demos, except for this one slide. Everything's going to be demos. You can check out all the related materials at aka.ms/DevOps for Java Shops. And please check me out on Twitter at bbenz. All right, let's get started. We're going to start with the code so you get a good idea of what we're actually using in this application. So I'll show you the end result, and then I'll build it from scratch to show you how I actually build it in Azure. But first, we're going to get it running locally. So this is a very simple Spring Boot application. I went to start.spring.io, and I built the basic application using Maven, and it just generates a little message that says, hello, Docker world. And the reason why I'm picking a really simple application is we don't want to really distract ourselves with the app itself. It's going to be more on how you actually deploy your app. So this is a very, very simple app that we're going to use so you can learn how to do that. The first thing we do, this is Visual Studio Code, and I'm using Windows Subsystem for Linux, WSL, which is a Linux implementation that runs on top of Windows. And these are some of the commands I'm going to use. So the first one I want to do is just check out and make sure that this connection doesn't actually have anything running. And it doesn't. Okay, good. I want to make sure. Sometimes I leave things left over. So we're going to actually build this application. What I've done is I created a little Docker file. It uses OpenJDK. It has the target is any jar file we have here. And the entry point is jar app.jar. So it's going to generate a file called app.jar, and then it's going to actually run that file. So the commands we use for that are over here. We're going to build it first. Docker build. Takes a second with the JDK. Now you could use a two-stage Docker file to make a smaller deployment version of this, but it's not really needed for a demo. It's pretty simple. As you can see, it just ran in a few seconds anyway. And then we're going to run it. So Docker run, and it runs on port 8080. It's going to start up, and it's Spring Boot Docker ACA. It's the app.jar we have. Okay, so let's try that localhost again. Hello, Docker world. Yay, it's working now. Okay, so we know it works. Okay, so that's all the application does. That's how it runs locally. So what we're going to do is we're actually going to take this application. We're going to post it to a registry. You can use any registry you want. I'm using Azure Container Registry for my choice, partly because I work for Azure and partly because it's easy for me. It's available. You can use Docker Hub. You can use others. And what we're going to do once we get it into a registry is we're going to deploy it out to Azure Container Apps, which is a way to run scalable applications in a Kubernetes cluster without you having to know anything about the Kubernetes cluster. So basically, Microsoft runs a big Kubernetes cluster. You grab a node and you put your application on it with a container, and it runs for you. It's the simplest way that we have to actually run and implement a container solution in the cloud that is scalable and runs on a version of Kubernetes. So check that out. What we're going to use to do that is something called ACR build. It's going to be a lot like the Docker build command that I just built. But what it's going to do is it's actually going to package up the application. It's going to post it out to the registry. Before it posts it to the registry, it's actually going to build the application in what we call the hosted agent, which is a application container environment that runs on our server. If it builds correctly and everything's okay, it's going to post it into a container registry for us. So the first thing we need to do to actually get this going is we're going to build a registry, and we're going to build the container app that we are going to use to place the application on from the registry. And by the way, anything you deploy to the cloud, any Kubernetes, container apps, our competitors' products for these sorts of things, has to have a registry to actually deploy from. So that's an important point to remember. You do have to have that registry in the middle when you want to deploy to pretty much anything. So let's get started. What we're going to do is we're going to use a blank version of the Azure portal. Here's an Azure portal that uses, this is DevOps or Java Shops. You go to portal.azure.com. If you don't have a trial subscription or a full subscription for Azure, you can get one there. Portal.azure.com. I have all of my demos that I use organized into portal dashboards. And here they are. And what we're going to do is we're actually going to create a totally new dashboard for this. We're going to create what's called a resource group. That's this square here that contains all this stuff. And then we're going to create a registry and a container app inside of that resource group. So it'll be more obvious as I go along, but that's basically what we're going to do here. So let's just hit create, and let's create a new portal. All right, that's all we need to do. Create a dashboard. We don't need any of these templates here. We can just close that. And we can create a custom dashboard. All right. From there, we can just call it how to build and deploy Java applications on Azure. That's, boy, my bad spelling. And we'll just save that. Okay, so now we got a blank portal dashboard. And what we're going to do now is we're going to create a resource group. So let's go in and find the resource group and create that. To do that, you just hit the little plus. I'm going to use a combination of the portal and CLI commands today, running in that WSL that I showed you earlier. So let's go ahead and find this resource group. So basically doing everything live for this. There it is, create resource group. And this one we're going to call CEE. Okay. Actually, let's just call this one Spring Boot to ACA. That seems like a good idea. And then West US 3. Let's go with that. There's multiple regions that we could put this in. And by the way, you can have things in your resource group that aren't part of the region that you create this in. But for me, I'll just do it this way. So it looks like the resource groups is cool. And I'm going to use resource group location, West US 3. Create. All right. So the resource group was created. I can go there and I can pin it to my dashboard. Pin. All right. So go to the dashboard now. We've got a blank resource group. So now we want to create a resource. The first thing we're going to create is that Azure Container Registry that I told you about, because we do need to deploy to the registry for this to work. So Azure Container Registry. There it is. Create Container Registry. All right, so there's nothing really special we need to do here. We're going to use the resource group that we just created called Spring Boot to ACA. And we're going to call this one Spring Boot to ACA. Why not? And it has to be a unique name at .azure.cr. Let me make this a little bigger for you. It has to be a unique name at .azure.cr.io because it has to be accessible from an endpoint. And it automatically chose the West US 3 location because that's where the resource group is. We don't need a availability zone for this. And we can actually use the basic version of this. Actually, I have to use the standard because I already have a basic one in my subscription. You're only allowed so many basic ACRs, Azure Container Registries, in your subscription. So I have to use the standard for me now. And that's it. So let's go ahead and create that. Create. And what it's going to do, it's going to take a second to build that up. Okay. So it's running pretty quickly today. That's good news. And I can pin this to my dashboard now. So I go to my dashboard now and I refresh this. You can see we have two things now. We have our container registry and we have another version of the container registry over here. This is the resource group that's containing this thing. This will give us a listing of everything. So I didn't actually need to add it to the registry. It was already there because it's part of the resource groups that's already there. All right, next, we're actually going to create an Azure Container App. Oh, wait, actually, no. The first thing we want to do, we want to actually generate the image inside of this container app that we want to deploy out to the in this container registry that we want to deploy out to the Azure Container App. So let's do that first. So what I want to actually do here is I want to set up my command with a resource group. If you notice here, it doesn't have one. Okay, so that should work now. Because what you can do with the Azure CLI is you can specify default configurations if you don't mention which ones you have. So if you look at the error message here, I've got a resource group that's not, this is not the one I want. So I need to specify the resource group in the actual command. Let me just put that right. Okay. Okay, that's what it did. So I had to change a little bit. Instead of group, I used G for group. So basically what this command is doing now that I've figured out how it works is, I knew how it works, but I typed it right. Let's put it that way. So AZ ACR build, it's a group Spring Boot to ACA. We're going to use the registry Spring Boot to ACA. And we're going to create an image called Spring Boot Docker ACA V1. And what this is doing right now is it's actually taking the code that we have on our local machine here in this GitHub repo that I've cloned locally, and you'll find the resources at aka.ms/DevOps for Java shops. And it's pushing it out to a host on Azure, what we call a hosted agent. And the hosted agents, oh, it's already done. So the hosted agents actually create their own container, have tons of resources in it, already pre-built and pre-made. And it'll run the Docker build command for me. If the Docker build command is successful, then it will actually deploy this out to a container registry that I specify. In this case, the registry is Spring Boot to ACA. And once it's done with that, it shuts down the hosted agent and moves on. And we can now use this to deploy to Azure Container Apps. So let's have a look at that resource in the actual portal. Here we are. Okay, so if we go down here to repositories, we just created this one. It should have exactly one. There it is. One repository, V1, and it's sitting there. It's ready to go. So we have a container, and it's there, and it's ready to be deployed to Azure Container Apps. So the next thing we have to do is actually create the Azure Container App and then deploy out. So there's a couple of things we need to do with this Azure Container App. So let's go in here, create. No, I'm using the wrong plus sign. Here we go. Create a resource. Azure Container App. All right. There it is. We're going to create this one, Container App. And by the way, you can do this all with the Azure CLI if you want to. I find this is just better for explaining it to folks. So we're going to use this Spring Boot Docker ACA. No, we're actually going to use Spring Boot to ACA. That's the one we're going to use when we create the app. And we're going to call this Spring Boot. Oh, has to be lowercase, yes. That's fine. Okay, so that should be okay. We're going to use West US 3, and there's a couple of specific settings that we want to use here. So let's click on App Settings. And we're not going to use a Quick Start image. We're actually going to pull an image from the registry that we just created. So we're going to pick the registry that we just created, Spring Boot to aca.azurecr.io. Oh, we do actually need to set up the credentials as well. I believe I'd already done that, but let's just make sure. So to do that, we can actually go back to the dashboard here so we don't lose what we've done so far. We go into our ACR. There we go. And let's look at what we have to do here is we actually have to enable in access keys the admin user. When you enable that, it gives you a username and a password and a couple other things. And when you set this up, obviously, well, I'm going to have to regenerate this after I show them. But once you set this up, it's automatically there. So next time you go in, it's already set up. So now if we go back here and we just pick some other sample and then we pick Spring Boot to Azure, should be okay now. Let's do this. Azure Container Registry. I might have to go back a step and recreate this because it's already cached that. All right, so let's go in, create container app, and we're going to use the resource group, Spring Boot to ACA, Spring Boot to ACA. All right, we're going to use East US. Okay, there is no East US or West US 3 actually is where the rest of everything is. So let's use that. Yeah, okay, next app settings. We're not going to use a quick start image. We're going to use Azure Container Registry. This time it goes through, yay, okay. So then we pick the ACA. That's a good point. So you need to enable those credentials. That's anyone's going to run into that before they can actually pull things from the registry. And the reason why I didn't need to provide the password and everything is because the information is already it's already inside of Azure because we used another Azure resource. It can actually pull and check things through Azure Managed Identity for us. We're just going to use the default for the actual CPU and memory for this, but there are several options. We don't need a lot of power for this. It's just a demo. We do need Ingress enabled, and that's so that we can actually access the HTTP endpoint. And you can limit it. There's a bunch of different things here I won't get into the details of. We don't want to allow insecure connections. And we're going to have a port of 8080. And now that I think about it, I think we're going to actually accept traffic from anywhere, and we're going to allow insecure connections because it's just a demo. The container apps environment itself, that's if you want to have things that only talk to other container apps. Then for traffic from anywhere, it's not really well worded, but it's from the outside world, which is the whole point behind Ingress. So yeah, you'd want that. And that should set everything up. So once we create this, just takes a couple seconds. So let's talk about this, what's actually being created. It's creating a container app. It's creating this thing called an environment. And this is something we're going to be able to use to deploy our application out. So it's actually gone. It's taking a few seconds. And there it is. So let's go to the resource. Actually, we don't need to go to the resource. We can just refresh this now. And now we have a container app and a Spring Boot to ACA container registry there. Now, because we already created the image, we should literally be able to open up this container app. When we click on the container app and we click on the URL for the application, because we've opened it up to the outside world, yep, there we go. So once we've opened it up to the outside world, all you have to do is create that application If you need to update it, you can update it from the registry. But the application is there, it's running, and it pulled the registry image into the container app on its first load. So everything's here that you need. So next, what can you do with this? We can monitor this. Right now, it's going to be pretty boring because there's just not a lot here. But you can look at CPU message usage. You can look at replica count. This is what I like. Replica count. Right now, it's going to be 1 replica. But let's test that out. I want to show you a little something else we have called Azure Load Testing. So let's go in. We're going to create a new resource. Azure Load Testing. This is currently in preview, but it's pretty cool stuff. What you can do with this is you can actually set up, I'll show you in a second here. You can actually set up a load testing environment that you want to use to test out your applications. Spring Boot to ACA. Let's call it Spring Boot to ACA. All right. And let's review and create. Just a really basic one. Going to create it. And what we're going to be able to do with this, it's based on JMeter, which is pretty cool. We can take our ingress point, which is this point here, hello Docker world. We can go back over here. Let's see here. It's still in progress. Okay. Looks like it's getting there though. Yay. Yeah, there we go. Okay, so it's there. So now if we go back into our dashboard and we refresh this. So now we have 3 things in here: a container app, a container registry, and Azure Load Testing. Let's open Azure Load Testing. There's 2 ways to run a test. You can load a JMeter script, which is built on Java, JMeter. You can do a quick test, which is you literally just point it at a URL like this. And let's do 20 virtual users. And let's just, 2 minute. So let's run the test. Okay, so what it's going to do now is it's actually going to fire up more of those hosted agents that I mentioned before. It's going to start them running. There are 250 virtual users per hosted agent, which is kind of cool. And then if you put 1,000 users in there, it's going to create 4 instances and start them up. In this case, it's going to use 1 instance. It's going to create that and it's going to start running. Once it starts running, we can go over here to our second view of the dashboard, the same dashboard. Let's refresh it. It's been a while. Okay, so now we can go back into the container app. And we can actually see down here in the metrics something a little more interesting when it comes to replica count now. So if you can see here, over here, oh, look what happened. It fired up from 0 to 1. All right, but that means that the load test hasn't started yet. Yeah, the test is going to run. It's going to start shortly. Just give that a second to get going. And there it is. It's fired up. It started running. And you can see here, the response time is not good. Now, here's where the purpose of Azure Container Apps comes into play. It's really not meant to be a highly scalable application environment. But as you can see here, there's a lot of requests coming in. And the response time actually is fairly resilient right now. So let's look at this, refresh this, the usage chart. Oh, it's only got 1 replica at the moment. But if we look at, for example, maybe I only set it up for 1 replica at the moment. I'm not sure 100% to be honest. Yeah, I think it's, oh, there we go. So 10, it's got 10 replicas running at a certain point there. It fired it up, it went in and it sped up to 10 replicas. If we go back to the metrics, and we look at other metrics as well. Whoops, I closed it. container app. Just a moment. Metrics. All right, let's look at CPU usage. CPU usage was fairly consistent, and that's kind of cool because, well, it created new replicas, so CPU usage was good overall. There's several other things you can do to look at the metrics as well. So if we go back over here to the test run is over. It had no errors, virtual users, and as you can see, no errors here, and pretty good response time. You know, it kept it solid the whole time while we run this, and there were 181 requests per second. Oh, actually, it's still going on. So 120 requests per second right now. So we can go back over here and see how the CPU is holding up. Yep, it's still constant. Still there, still running. And that's it. Okay, so that is basically everything I had to show you. If you want more details on how this is all set up, check out aka.ms/DevOps for Java Shops. My name is Brian Benz. I'm a cloud advocate at Microsoft, and that was enabling reliable code delivery for the cloud with container apps. You can find me on Twitter at bbenz, and I hope you enjoyed that. Thank you.
All right, thank you, Brian. That was a great session. And guys, we kind of got a bonus of kind of a learning about two additional things. First was the Azure Container Registry, where you can kind of store and build your Docker images and use it to deploy to the container apps. And the second part was the Azure load testing with JMeter, which I think it's a great addition. Amazing presentation. So let's move forward and we'll have Steve talking about the Azure Spring Cloud. Steve, it's your turn.
Hello, welcome to this Java on Azure webinar. My name is Steve Pinko. I am an application specialist, and today I'm going to present you different options to modernize your Java workloads on Azure. The Java ecosystem is broad, and Java supports your Java workloads with an abundance of choice. To land on Azure, I see three patterns: lift and shift, modernize using containers, and modernize through PaaS platform, which could be manage Tomcat, manage JBoss EAP, or manage Spring. Now, let's have a look at Azure Spring Apps, which is a fully managed PaaS service for Spring Boot apps. It is co-designed, co-supported both by Microsoft and VMware. It provides a fully managed infrastructure, built-in application management, and all the tools you need to monitor your applications. You can use Azure Monitor, of course, but it does support as well third-party solutions. If we look here about what you would have to do if you would build everything on your own, you would have to take care not only of the application, of course, but also about the underlying platform, about the monitoring, the logging, the patch management, and so on. The purpose of Azure Spring Apps is to make your life easier and to offload all the burden of this infrastructure management. To avoid any confusions, I think it's important to share a few words about the Spring world, because Spring has a broad ecosystem. So, you know, the Spring framework, then you have Spring Boot, which is the easiest way to just deploy an application which just run. Then you have Spring Cloud, which is a set of projects to help developers to quickly build resilient apps based on common patterns for distributed systems such as configuration management, service discovery, and so on. So in a nutshell, Spring Cloud for Azure is an abstraction layer of the Azure Java SDK. Finally, Azure Spring Apps is a fully managed service running on top of AKS. Spring Cloud for Azure is a very easy way to consume PaaS services from Azure. So, for instance, your app may need to connect to a database through Spring Data, to connect to MySQLDB, as we will see then in the demo, or to integrate with Key Vault to store your secrets. So about Key Vault, this is a solution to avoid security incidents with secrets leakage. Your applications can securely access the secrets, and you can then configure role-based access control on Key Vault to ensure that only your identified apps identified to their own identities have access to those secrets. Here, this is the reference architecture of Azure Spring Apps standard tier. It is a hub and spoke architecture. So here you will notice the built-in software components with the Paketo open source build service, the config server, the discovery server. You can leverage other Azure services like Application Insights, Key Vault, Microsoft Defender for Cloud, and of course, you can deploy your business applications into your VNet, configuring here a private DNS zone. If we look here at the reference architecture with the enterprise tier, this time you will get some extra components like the Tanzu build service, the API portal, and the Spring Cloud gateway. So looking about the details of the enterprise tier, you will get the VMware Tanzu build service, which is the commercial offer from VMware, which uses cloud native build packs and Tanzu build packs. The Splunk gateway for Tanzu provides you solutions to quickly route your client request to your backends, addressing some cross-cutting considerations like rate limit, for instance. You will get as well the API portal for VMware Tanzu, and you will get the VMware Springtime runtime, including extended support compared to the open source support timeframe. Some concepts in Azure Spring Apps. Apps and deployment. An app is an abstraction of your business app. One version of your code is deployed as the app into a deployment. You can then define a staging or a production deployment. Now, this is the scenario I propose you for this webinar. Say you have 42 new apps to go live every 42 days. The requirement is to innovate, so you are encouraged to modernize to PaaS services. So in this case, it's different. I don't need to write a Docker file. Azure Spring Apps will kindly take care of all the build for me. I just need to provide my my applications. I will provide here a jar file. So we'll see then how to parameterize the configuration, how again to secure the secrets using Key Vault, and how to leverage the monitoring tool. But before we switch to the demo, let's have a quick look at the high-level architecture when we design the app with Azure Spring Apps. You will notice some slight changes. This time, I don't need to deploy and manage the config server. It is already fully managed by Azure Spring Apps. It also provides a built-in discovery server. So each of my app will register to this discovery server. And for instance, the API gateway will register to a discovery server to get the IP addresses of each microservices. Now, if we switch back here to my browser. Yes, this is the same pet clinic applications deployed in Azure Spring Apps. So if we have a look here in the portal, this is my resource group. I have my application inside my Azure Spring Apps, the managed entities, log analytics, workspace, MySQLDB, eventually storage account. It's not mandatory. It's just if you wanted to upload your jar file to a blob storage to then deploy them from your pipeline. Now let's have a look at the Azure Spring Apps here. And we can have a look at the config server. It is completely managed. I just provide the Git URL to connect to. So this is my public repo on GitHub, and it uses the main branch. So I can show quickly here. So this is, yes, the config repo which is used with my application.yaml, and basically it stores all the required configurations to integrate with Key Vault and to store the MySQL connection string. Now we have seen the config server. What about the pipeline? So the first thing, I need to build. So this is basically a Maven build, and then here I have a deployment job. So basically, I deploy each of my microservices. So if we have a look about what it could look like in terms of code, in VS Code, you can use, for instance, a GitHub action, which is provided for you, which is Azure Spring Apps Deploy. I provide my subscriptions. I want to deploy, for instance, to a staging environment. I provide the Azure Spring Apps Service instance name. I say I want to deploy this microservice. In this case, it's the vet service. Yes, I want to use a staging deployment. I provide the package. So this is the jar file. And so in my workflow, it's one of the outputs of the previous build job. And I can provide the environment variables here, like the endpoint and others. I specify the runtime version, which is Java 11 in my case. Now, if we move back here to the portal, I go to Azure Spring Apps. I want to have a look at my apps. And I go, for instance, to the API gateway. And I go then here to deployments. And I have one deployment, which is the blue one, which is in fact the staging deployment, and the green one, which is running on production. If I go to the green one, and I have a quick look about the configuration. Here, yes, I will, as you noticed, the runtime platform is Java 11, as I have requested. And here I have some JVM options. I have as well the environment variables, including, yes, the Key Vault endpoint and some identities. Now, we have seen the deployments. Yes, I've missed one point, which is the routing. If we go back to here, yes, sorry. Yes, this is again the API gateway project, where here I have this application.yaml files. It uses again the Spring Cloud gateway. And basically each time I will call /API/mybackend. the traffic will be routed to the correct backend. And this time, I set, for instance, for that service to call http://that service. Why? This is because that service is exactly the name of my app, which is declared here in Azure Spring Apps. Okay, so last thing to check the monitoring and App Insight. Yes, so monitoring. This is another query which I have built to check the errors as a pie chart, and I have some errors here coming mainly from the API gateway. Now, if I come back to Azure Spring Apps and I go to App Insight, Application Insight, and I click here on Application Insight, I want to investigate, and I click on the application map. I want to investigate what are the dependencies between the services. I want to check what's happened since 2 days. And yes, so here I have here the API gateway. I have my microservices. They all connect here to the config server. I have as well the backend services which do connect to MySQL DB. And yes, each of the three backend 1, 2, 3 do connect to my Key Vault. All right. I think we've seen the portal experience both for Azure Spring Apps and Azure Container Apps. So yes, conclusion. To wrap up, the value propositions of our PaaS services is to lower the administration's overhead. So both Azure Spring Apps and Azure Container Apps are much more than managed communities. They are applicative platforms offloading the infra operations burden, providing integrations for Spring Cloud for Azure, Azure Monitor, and other PaaS services like Azure Databases and Key Vault. In terms of agility, with Azure Container Apps, you can run multiple continuous revisions and split the traffic across multiple revisions of an app to enable blue-green deployment or A/B testing scenarios. Something important to mention, you can scale down as well to 0. One difference as well compared to Azure Spring Apps, you do not need to deploy the Eureka Discovery Server as it relies on AKS, so Kubernetes, which comes with its own service discovery. Having said that, you still have to deploy and manage your own config server. Azure Spring Apps is a bit different. It provides managed components for Java applications, including the config server. It has some built-in build service. It supports blue-green deployment as well. It supports the App Insight Java in-process agent auto instrumentation. So in a nutshell, you don't need to configure anything. Everything will be configured for you so that you get the application map, for instance, in the portal. And you can scale based on metrics, including some Java-specific ones related to the JVM or related to Tomcat. So to summarize, Azure Container Apps and Azure Spring App has a different approach, different features. And one key difference is that while Azure Container Apps is language agnostic, Azure Spring Apps provides faster onboarding for Java developers deploying Spring Boot apps. I hope you enjoy these sessions. You are now ready to modernize your apps on Azure. Thank you.
Thank you, Steve. Great content. And guys, here you have it. If you're having an existing Spring application or you are planning a new one, there's a home for it in Azure, so definitely make use of this service. With that, we are moving to Brian. Brian, take it away.
My name's Brian Benz. I'm a cloud advocate at Microsoft, and I'm here today to talk to you about perfecting Java CI/CD with GitHub Actions. This is a 100% demo. This is the only slide you're going to see. I just wanted to show you this so that you can follow along if you want to at aka.ms/DevOps for Java Shops, where I have the source code I'll be showing today, as well as instructions on how you can set it up. Let's get started. First thing I want to do is actually show you the application. So this is the application that we're going to build from scratch in the next 25 minutes or so. But this is it. It's a Spring Boot application. It runs on Java. It runs on something called an Azure Web App. And it's connected to this thing called a feature manager. So a feature manager allows you to add features to your application without changing the source code. And the way you do that, I'm just going to go into the Azure portal here. I can click on one of these features. This feature is called Beta. When I click on it, it updates the feature flag. And when I go back out to my application and refresh, there's a couple of changes, but the most notable one is that we have a picture of our developer advocate bit that is displayed. That's the feature that I'm using for this demo. Like I say, just a simple Spring Boot application, but this feature could be anything. And you can do more than just turn it off and on manually. We'll be talking about that towards the end of this talk. So, all right, so that's basically how you do. This is what the application looks like. You can turn on and off that feature, and we're going to deploy this out to an Azure Web App, and we're going to connect it to that feature flag. I like to show this demo because it's not just a simple Hello World standalone application. It actually has a connection to something else, which is what most applications out there in the real world do. They usually connect to something or other. All right, let's get into how you actually build this. We're going to start in the Azure portal. The Azure portal is your starting point for everything. It's portal.azure.com, and if you don't have an Azure account, you can go and get a free trial at portal.azure.com as well. And what we're going to do here is we're going to create a new web app. This is the application I showed you is running on a web app. And we're going to deploy that out to Azure, and we're going to use GitHub Actions to do the deployment. So let's get started. We're going to go into the portal. We're going to create, I should mention, let me back up a little bit. This is a resource group. That's important to remember. This little square here is a resource group, and this is where I keep all my resources. My resource group is called DevOps for Java Shops. I'm going to create a new web app inside DevOps for Java Shops so I know where it is and it's easy to find and everything's grouped together. Okay, back to creating the web app. Create. And we're going to use that resource group, DevOps for Java Shops. We're going to use a web app name of dev CI/CD for Java. Let's see if that's an okay one. Yes. Okay, so it has to be a unique name at .azurewebsites.net, which CI/CD for Java is. We're going to publish code, but we could use Docker container or a static web app as well. We're going to use a runtime stack of Java. We could use many others, as you can see here. Node, PHP, Python, .NET, of course, Ruby. We're going to show the Java 11 for this. We could use Linux or Windows. We're going to pick Linux, and the region we're actually going to deploy this to is West US 2. The reason for that is I already have an app service, what they call an app service plan, which controls the performance of the app, built in to West US 2, so it automatically chooses it for me. It just makes it a little bit quicker for demos. Next, we're going to do a deployment, and this is where the CI/CD comes in. So we're going to enable continuous deployment. We're going to use my GitHub account, bbens, and what we're going to do is we're going to go out to my bbens organization. We're going to use a repository called DevOps for Java Shops test feature flags. We're going to use the main branch, and we're going to review and create this. There's nothing else we need to do. Everything else can be the default settings. And what this is actually going to do is two things. It's going to create the web app for the target code to run on, but how do we actually get the code there? It's going to create what's called a GitHub action. That GitHub action is going to do the deployment. Let me click create while I'm chatting. That deployment itself is going to be controlled by two different jobs in GitHub Actions. And I'll explain what that is in a minute. But this is actually going to fail the first time, which is why I like to show it. Because when you're doing simple things, it's very easy to show how everything works perfectly. But if you're doing something like connecting to a feature manager from your application, you have to be able to handle that in your GitHub action and actually in your web app as well. So this deployment is going on. It is, looks like it's deployed, CI/CD for Java, but let's just give it a second here. Yep, there we go. So the deployment is succeeded. Technically, that's true, but because it created the resource, but it's not true in the sense that the application's not running. So if you go to CI/CD for Java and you click here, it tells you, hey, hello, hey, Java developers, this is the screen you get when your code didn't make it to your web app. This is just a blank web app ready to go. It knows it's Java, but there's no code running. And now, because it's a Spring Boot app, there is a default site that we've specified in the Spring Boot app, but still it's not working. So how do we get that to work? We have to go into our repo, which, as you may recall, is DevOps for Java Shop's test feature flags. Inside that repo, here's the action, and the action has failed. So the action has failed, and I already know what it failed, but I'll show it to you folks. When the build with Maven runs, it looks for that feature flag, and it will not build properly unless that's done. So that's basically where we go with that. Unfortunately, that means that we have to, let me scroll way back up here. Scroll way back up here. That means that we have to fix this action. So to fix the action, we actually have to add an envar. So you go into GitHub Workflows. This is where the GitHub action was placed by the web app deployment process. It's called CI/CD for Java. And we actually need to update this with an environment variable. That environment variable is hidden in this repo, but the action that we caught is automatically generated, so it doesn't know where it is. I need to edit this GitHub action. So I could do that right here. I could edit this, but that's not really good software development or DevOps practice. What I'm going to do is, instead of cloning this, making a change, and then pushing it back out to the repo on GitHub, which will, by the way, trigger that workflow to run again, I'm actually going to create something called a code space. Code spaces are this cool, relatively new thing that allows you, here's what you're used to in your GitHub repo. You know, you can clone this. If you go over here to the Code Spaces tab, I can create a new code space. What this is, it's going to clone my repo into a container, and that container is running on something called a GitHub runner. And that container is then going to basically have all my code plus Visual Studio Code in it, ready to go for me to make any edits. And I push out, just like you would any clone, to my repo when I'm done. So if I go in here to my GitHub Workflows, this is the one I just showed you a minute ago, it's missing that reference to the environment variable. Here's the reference. This is a previous workflow that I keep here just so I can do this. So this is the old one. I can just add this. It's disabled, but I can actually add this to my new working repo, new working action, and then push it out to the repo. So this is, just bookmark this for a second, this extension pack for Java message. They want us to install something to run here. We don't need extension pack for Java to update the GitHub action, which is all we're doing. So I won't install it, but I'll talk about that in a minute. All right, so I'm going to save this. And you can see over here in the code source control tab, we have one file that needs to change. So we're going to say update vars for CI/CD. Okay, and let's commit that. So it's asking me to stage it, and then I can sync the changes just like you would from a local repo. It's pushing it out there. Let's talk about what this repo does, or I keep saying repo, what this action does when you're actually doing this. This is the action itself, and now it's got a reference to a secret, which we use as an environment variable in this action, and I'll explain those in a second here. But let's talk about the action itself. So anytime there's a push on this repo,
code pushed to the repo. On the main branch, it's going to trigger two jobs, a build job and a deploy job. So the build job runs on, let me make this a little bigger for you. The build job runs on Ubuntu latest. It checks out the code. It builds it using Maven, which is what you saw failing before. And then assuming it's successful, it builds a jar file. Then there's a second job that runs on another GitHub runner using Ubuntu again. It grabs the jar from where it was placed and it deploys it out to the web app. It uses a token. Once again, we've got a reference here to something. This token is also secret and not available to everyone who looks at this. So if you clone this repo, you can see this action, but you can't see these secrets. The secrets are over here. If I go into the repo itself and I go into settings, the secrets are action secrets. You can also set up code space secrets. Here they are. So the app configuration connection string is the one that refers to the feature manager. It's hidden and it's only in my clone of this. If you clone this, you won't have these secrets available to you. You have to create your own. It also creates this, the deployment process we had for the web app creates this token that we use to secure the connection between the GitHub repo and the web app, which should be obvious why that's desirable. So those two secrets are in this repo and they won't be in any other clone or fork of this repo. All right. So if we go back in here and we look at our test feature flags now, fingers crossed, yay, it ran and it deployed properly. So the actual deployment worked this time. Remember down here, this one didn't work. The build was successful, so it's got the whole job. The deploy was successful, but the web app's still not going to run, and we have to fix one more thing before it runs. But if I look here at deploy to Azure Web App, it tells me that the web app is here. I click on it. Takes a second. There we go. So this time we don't get that generic screen, meaning that the code was deployed, but it's still not working. And the reason for that is because we connected the feature manager in the app together with the action, but we didn't connect the feature manager and the app together in the actual runtime app itself. So we have to do that as well. So let's go into our resource group over here again. And I can find, as I mentioned, that's the reason for putting in the resource group is I can find it easily. So the web app itself is there, everything's running, it's cool, but inside configuration, we have to set up a connection between the feature manager and the actual application. So let me just copy I've got a copy of the connection string over here. Don't look, you can't see it all anyway, but that's okay. All right. So basically what that does is makes the connection between the app, and I remember to save it, which I don't always do, and the setting itself. So once this gets done, it updated. Let's go back out to our web app now. That's the old one. This is the new one. And there it is. I didn't change anything. It just took a little while to update the app. But there it is. Now I can control this. If I go back into the feature manager, I can control this. I can turn on and off the beta. There we go. So if I turn it off, refresh it a couple of times, and bit is gone. All right. So I mentioned before you can do more with Feature Manager than just turning on and off manually the feature. And to do that, you create a new feature. And this, let's call CI/CD for Java. Okay, and we'll create it. And then what you can do with that is you can actually edit it. Let me go over here. And I can apply a feature filter. There's different kinds of feature filters: targeting, time window, and custom. So the cool thing about these is you can say targeting would be a certain location or a certain group of users get to see the new feature, others don't. Time window, of course, is it's a certain time, maybe a weekend or a holiday or a certain period of time that you want to see this feature and then you want to get rid of it. And there's also a custom. The custom is a default percentage, or a custom can be a percentage. So the percentage itself can be 50 up to 100. You can also set up a group and users. So you can set up a group and users for targeting. You can also set custom, which would be 100% percentage. If we go in here and we say okay. Then you edit the filter parameters. You put a value of 50. Apply. There you go. So now there's a Microsoft percentage of 50% that's going to be used. Anytime anyone looks at this, it's going to be 50%. You can also change that value later by increasing this percentage. There's two things you can do with this. A/B testing is where you have a new feature. You're not sure if that feature should be implemented, so you give it to a certain percentage of your users. You track and you monitor their behavior to see if it does actually what you intend it to do. The other is blue-green deployments, which is where you have a new feature, you're going to roll it out gradually. You're sure it's going to be implemented. You just need to roll it out now. So you could gradually increase this percentage from 50, 60, 70, 80, 90, till it's 100. And then the next time you do a deployment, you can deploy out to the application with the core code and then start over again with a new feature. So that's A/B testing and blue-green deployments. So that's everything I want to show you today. We have a total of all the repos that we showed you. We showed you how to use feature flags. We showed you how to create a new web app and deploy that out to Azure using the portal. You can also use something called the Azure CLI to do this as well. If you need more information on any of this, check out aka.ms/DevOps for Java Shops, where I have the source code, and also follow me on Twitter. Thanks.
All right. Thank you, Brian. And guys, that's how you deploy your jars to the Azure Web App Service. Great service. But I think that we got a little bit of a bonus here looking at the GitHub code spaces, which is also a great service if you want to code and you don't want to use your local development environment or you have restrictions to use one. You can do this in the cloud. So great presentations. With that, we are moving to our next presenter, Bobur. It's you, man.
Hi everyone, welcome to one of the sessions, Java on Azure. This webinar shows with simple scenario how to build serverless Java solutions using the power of serverless event-driven computing like Azure Functions that ingests a stream of data, processes data, and writes the result to backend database such as Azure Cosmos DB in real time. Let me introduce myself. My name is Bobur and I'm a developer advocate. If you have any further questions about this webinar, please feel free to reach out to me on the social channels. I will be happy to get the feedback from your side. So with that, we can get started. Serverless architecture with functions is an example of event-driven architecture. The function code is triggered by some event that's external to the function. In this case, either a message comes from the device or an HTTP request from client application. And with this Azure function has a lot of benefits. Let's say with the function app, you don't need to write any code for the trigger. You only write the code that runs in response to the trigger. I mean, that means you can focus on your business logic rather than writing a lot of code to handle infrastructure concerns like messaging. Java in Visual Studio Code provides a good overview of the most popular Visual Studio Code extensions, let's say for Java development. It also provides instructions for getting started with development using Visual Studio Code, along with a walkthrough of how many ways it can help make Java developers more productive. And Azure Toolkit, let's say for IntelliJ, Java developers can create, develop, test, and deploy Java applications to Azure using the IntelliJ IDE. Or the deploy the serverless application to Azure Functions. And we have also, there is a Maven plugin for Azure Functions that helps you deploy Maven serverless Java applications to the Azure Functions. And it's very similar to Gradle plugin for Azure Functions that does similar things that the Maven has. Last one is GitHub Actions. It makes it easy to automate all your Java software workflow using world-class CI and CD tools. You can build, test, and deploy your code to the Azure right from GitHub. For example, Azure Functions have a bunch of built-in connectors like Azure Event Hubs to process event-driven Java code and send the data to the Azure Cosmos DB in real time. We have real projects like FedEx or UBS projects are great examples of real-time and event-driven in Java. This architecture, let's say, shows a serverless event-driven architecture that ingests a stream of data, processes the data, and writes the result to the backend database. If you look at the workflow, like events arrives at Azure Events Hub, and the function hub is triggered to handle the event, and then event is stored in Cosmos DB to handle that event. If the function hub fails somehow to store event successfully, the event is saved to the storage queue to be processed later. Let's take this example, and we can break down now each component in this event-driven architecture and learn how they can be useful for our example scenario. Assume that we are receiving telemetry data from a device with a simple sensor connected that measures temperature and the pressure. Function in this case just simulates telemetry data generation, the first function, and it sends events to in an event hub in the next step. Later, another function can listen to this event and process and store it in database created with Azure Cosmos DB. The generate sensor data function, as I said, as a simulator, it sends the temperature and pressure readings to the event hub, and the timer trigger runs, let's say, every 10 seconds. And it sends the event hub output binding to return the value to the event hub. Next, event hub registers the new event. For example, Azure has event hub is one of the products offered by Azure to create event-based solutions. It's mainly focused on the big data. It decouples the producers of events from the consumers. When the event hub receives the message, right, it generates another event. For example, for Internet of Things scenarios, you can also use Azure IoT Hub. IoT Hub has a built-in endpoints that is compatible with Azure Event Hubs API. So you can either use a service in this architecture with no major changes in the backend processing. So for more information, see connecting IoT devices to Azure. And this deployment shown here resides in a single Azure region, for example. However, you can take the advantage of geo distribution features offered by Azure to make your system available all the time. Next, talk about Azure function that processes the sensor data. Here, the main idea of working with Azure functions is that allows us to subscribe the messages sent to Event Hub, and we can later process each event individually, right? And in case of failure, we have this queue storage. It's used for dead letter messages. Let's say if an error occurs while processing the event, the function stores data, event data in this queue for later reprocessing. It certainly increases the resiliency of our system, right? Not every data storage solution is fast enough to meet the requirements of event-driven architecture, especially if you expect the response times in real time. There are many requirements for storage solutions. For example, it should be fast, non-blocking write access and read access. It should have a high throughput and should be scalable. For example, Cosmos DB that we are using in this architecture is a multimodal database service that's available in serverless. For this particular scenario, the event processing function stores JSON records using the Cosmos DB SQL API. And the function stores exactly one document per service that's sending data, like the temperature and pressure data, and the function continuously updates the document with the latest device status by using an upsort operation. But what about monitoring serverless event processing? Because most event-driven architectures use a fire and forget model. With a fire and forget model, the originator sends a message and doesn't expect any response from the recipient, right? And we shouldn't forget to monitor each piece of infrastructure and the whole system properly in this architecture. We can use Azure Monitor to monitor the Event Hub. It's also capable of collecting performance metrics about serverless application and built using Event Hubs or Azure Functions. You can have a look at some of the options in this slide that Azure Monitor offers. Or you can just simply scan this QR code and learn more about how to monitor event processing. In the later stage, you can use GitHub Actions to automatically build, deploy your code to your function app in Azure Functions. For example, in GitHub Actions, workflow is an automated process that you define in your GitHub repository. The workflow is also defined by a YAML file in the special PaaS like /.github/workflows in your repository, just under the repository. This definition contains various steps and parameters that make up this workflow. By enabling GitHub Actions, we can make sure that every change you do on the functions will be deployed to Azure Function App after it gets merged to the main branch. GitHub also supports the development containers for Java, which you can access via GitHub code spaces, or you can use a VS Code remote for the containers. On this slide, as you can see, there are some other the tools that can be helpful. I mean that Azure integrates easily. Let's say you can also provision the services with a Terraform, or you can build your services Maven or Gradle and manage your dependencies, or you can deploy your service to Azure using a command line interface or GitHub Actions, as I mentioned, or Azure DevOps tasks. Basically, you can learn more about Azure and GitHub integrations with it just by scanning this QR code. In addition to this, Azure offers an open source Azure SDK for Java programming language that simplifies provisioning, managing and using the Azure resources from just right from the Java application code. To implement infrastructure as a code in Java, you can use management libraries of this Azure Java SDK. With these management libraries, you can write configuration and deployment scripts to perform the same tasks that you can do through the Azure portal or the Azure CLI or Terraform. There are plenty of samples available on how to use this library. You can check them on the ARM sample client library for the GitHub repo. For example, look at this code in Java, how you can define first the necessary Azure services for your Azure Function app. You can create the first the storage for your Azure function, and even you can define where to deploy this Azure function with app service plan. So with this theoretical knowledge in mind, we can jump into the demo now. So source code you can find for this demo under my GitHub repository called event-driven Java App Azure. So you can find here the simple example how to build a serverless Java solution. You need some of the things before you get started. Like you can see the prerequisites. You need to install the Azure CLI on your machine, or you should have a GDK version of 8 or above. You can also install the Maven, and we are going to use also some of the Azure Functions tools, so you need the Azure Functions core tools. In my case, I'm using Windows machine and all these 4 things set up. And after, you can just clone this repository with Git, and then navigate to the folder containing this source code. You can just run the following commands, but before that you can just specify the environment names like resource group or the event hub namespace for the storage or function app. You can just run these commands on the Azure CLI, or after maybe you can install, you can directly use the commands from your command line interface. And also just go in order to run these commands. It will create for you new resource group by the given name, and it will create event hub with a namespace and some authorization rules. It also spins up the Cosmos DB for you, and also it will create the function with its storage inside. And this follow commands will do some connection string matching, and it gets the connection strings from the data sources to your Azure function settings. And then after you're done, you can go to Azure portal, and you can see on Azure portal I have new resource group created called Java event based. And then you can see some of the resources inside this Azure resource group. Like we have rolled out the event hub namespace, application insights, storage, and the function app used for the functions. And you can see also Azure Cosmos DB account created, and we have the one app service plan. In total, like 6 resources up and running. If you go, for example, to Azure Function app called event regular Java function, so far I have just stopped it. We can start it after we go and deploy in the next steps the functions inside the function app. Now, if you go to the source code that you cloned locally, you can see I have some of the resources here. This is the project folder, and if you navigate the POM XML file, you can see some of the libraries we're going to use for this demo. Because we are building Java applications, we need let's say Azure Function Java library to create some Azure functions in Java, and we need also a Maven plugin for Azure Functions to run and this Azure function locally, and maybe the later stage deploy it. And we have some other dependencies for the unit test, etc. And also, as you can see, if you go navigate the source folder, you can see some of the functions we have. In my case, as we discussed it earlier on the slides, we have three functions. Like one of the first functions that generates the sensor data with the temperature and pressure information to simulate the device, right, and runs every 10 seconds. In functions, for example, you can also specify what will be output. In our cases, output of this function code runs, it will create new event and sends this event to the event hub. And the next step, the second function, which is processes the sensor data, starts to run after it sees in the event hub there is a new event, and it will trigger a new event. And this code will run, do some kind of logic. In my case, just a simple logic to identify if pressure is above some sort of degree or the below, and then it writes the result back as output to the Azure Cosmos DB. If something happens while processing this data, as you can see, we're gonna put this data into the queue. Or if something that failed, the queue restarts and does the same operation in the previous step. But in my case, there is no logic yet, but you can always improve that. If there's a failed message, we need to get this message on to this function. Another interesting thing is with the capabilities of Visual Studio Code, you can see in separate model like Java projects, and you can also run some Maven commands from just right away from the VS Code instead of running in command line interface. Also, you can see where I have installed the Azure extension here, and it shows currently available your resource groups, and also it shows some of the subscriptions, and it also identifies automatically what are the Azure functions you have in the current project. By using Azure core tools, you can run some Azure function commands from your terminal right away. For example, let's try to first fetch some Azure Function App settings from Azure to run our app locally, because we need these local settings. And following command, let me put it this command. Following command will generate the local settings for you. It will fetch the settings from actual Azure Function App on Azure portal, and it will create a new file. Let's run this command, and for some time it will generate some local settings JSON file that you can see, and you can see some connection strings also copied from the Azure. So next we can try to run our simple application locally. To do that, we need to, of course, first do Maven clean package to create some build files by using Maven plugin for the Azure functions. I need to download some necessary dependencies right away. And now here we go, we have a successful build, and the next step we can use the same Azure functions Maven plugin to run our functions locally. To do that, you could just run the Maven Azure functions run command, and it will run now the functions locally. It takes some time while it builds and runs three functions. As you can see, these three functions up and running, like a sensor generator, processor, and queue. And we can see some upcoming messages like Java time trigger start to work, and then after event comes generate sensor data, sense event, arrives at event hub, and the next function event trigger function takes the job over, So far we don't have any failure, so because it simply generates the data, generates some random temperature and pressure information. So with that we are able to run our Azure function locally inside by using VS Code. Let's say you can just develop your Azure function and get some settings and test it locally. Also, and after the next step, we can try to maybe deploy these changes to Azure. We have many deployment options from VS Code. We can use Azure extension, or we can just run the command line. Let's try to use maybe the Azure function extension. Here, if you navigate to workspaces, you can see the functions list, and then click deploy, and deploy the function app. And you need to choose which resource group you're gonna deploy, or which function app you would like to deploy. I will choose my event triggered Java function app, and here we go. And approve that we would like to override the changes and deploy our new function. It takes for a while, depends on the changes, number of changes, and it's also proposing me to use Azure Developer CLI to do that. Now deploying started, and we can also check the output window to see what's happening, and we can just follow the logs to track the deployment status. As you can see, the deployment has been just started. Now we need to wait for a while so our change is reflected on Azure. After 1 or 2 minutes, you will get the deployment successful message. Now we can go to the Azure portal and check deployed functions. Now I am again under my Java event-based resource group. If you navigate the Azure Function app that we just deployed, new version, and you can see the functions available here, 3 functions, and they are up and running. And also you can see the deployment center here. Inside the deployment center you can see some logs at what time exactly we did this deployment and who is the commit author. Commit author actually in our case VS Code. Or you can navigate for example deployment slots. If you would like to have a different environment, you can create like staging environment or production environment. These deployment slots are available not only for function apps, for other Azure services as well. With Azure Functions, you can receive events from all over the world. For example, we can check processed events and saved events results on Azure Cosmos DB account. If you navigate to events data account and then select the data explorer, select the telemetry DB that we created this DB for our telemetry info, and then select the items to view your data that arrives. As you can see, we have many event data already arrived because our functions running every 10 seconds. It can generate many events. This is the one side of seeing the events and some kind of way of monitoring how the data arrived or data processed. Now let's look at the metrics in Application Insight to measure the performance and identify some potential bottlenecks in our event-driven solution. And now you can assume that your functions running in Azure and continuing to accumulate data, and in the database you created called Azure Cosmos DB. We can also view our deployed functions in Azure portal, or check the app telemetry through the connected Application Insight resource. If you go to Application Insight, for example, and you can open application map. Application map shows you or gives you idea how dependent your services are with each other. For example, our function app depends on the Azure Cosmos DB, right? Or you can go to live metrics and to see some live metrics happening, and now we are connecting the live metrics stream. And now you see some of the traces are coming every 10 seconds. So you can just have a look the overall health of your events and how the function app is processing data. Or to investigate the performance of your application stack, have also closer look at the performance tab to see some operations and dependencies and the roles. Each of these sessions gives you very deep insights, like for example, how much time it's taking your functions running, like generate sensor data, process sensor data. If you want to be always sure and your functions are running correctly, if something goes wrong or behavior, you would like to check the behavior. What happened when something failed? You can you can also set some alerts, automatic alerts to receive when function cannot process the data. It will create some alerts, and you can maybe receive some alerts messages to your email address to take actions on these alerts later on. As you remember, in the previous step, we deployed our functions when something updated manually, right? It's already we don't have any kind of automation. Now, as we can try to maybe enable the GitHub Actions to bring our changes on each Azure functions automatically when it's merged to the main branch. To do that, we can go to first our Azure function app. There are two ways of publishing it. The most preferable way is by using the publish profile. You can download this publish profile and save and keep the copy of the content somewhere. And then next you can go to our GitHub repository and navigate to the settings and open the secrets page. So if you open the secrets page, choose the actions. As you can see here, I added one repository secret. If you don't have any other yet, you can create a new repository secret by clicking new repository secret, and you just provide the secret name for the name field and copy the content of published profile that we downloaded in the previous step and paste it here and add secret. Click add secret. In this case, you will have this result here. Now what we did connection authentication between Azure function and GitHub. Next, you can navigate back to the project folder. As you can see, I have the new folder called .github, and I have GitHub Actions YAML file. You can just follow how to get started with GitHub Actions and Azure Functions. To create your first workflow. This workflow helps to automate a little bit deployment to Azure App. As you can see, under GitHub Workflows folder inside the GitHub Actions YAML file, we have some jobs and steps are specified. Let's say we have several steps here happening. Let's say we are first building our Azure functions by using proper Java version, and we are also before that we are checking out the GitHub Actions, and also we are restoring some project dependencies using Maven, and we are using also a special action called Azure/function action that is helpful to deploy the Azure Functions app using GitHub Actions. And do not forget to also specify some environment files here. And also we need to specify the publish profile name that we created on the GitHub portal. As you can see, it should match the same name like of publish profile. Uh, the same as here, like Azure functional publish profile. Once the GitHub Actions set up, we can try to test it. For example, we are trying to change something on functions. Let's remove maybe for the simplicity this command and click save these changes. If we commit and push these changes now, let's provide the commit message, remove comment, and if you click commit and push, it will push these changes to directly our main branch. And after, if you navigate to GitHub to see the result of build, you can navigate to actions tab, and then you can see a new build, new workflow is running. If you open this new workflow, now GitHub actions triggered because we had this setup. You can see the on leave some kind of logs from each step. First step, like we check out the GitHub action, we set up the Java SDK, we are restoring some dependencies, we run Azure functions, and then after for a while you can see that this function changes deployed to Azure automatically. This is how these CI/CD things work with Azure function. So our deployment has been just finished, and then we can check, for example, by navigating to deployment center. We can see the logs to prove that the deployment has been finished. You see, and now in the first case we used manually from VS Code we deploy Azure function. In the next step we enable the GitHub actions. Now we build CI/CD on the top of event-driven solution. When you finish with the work or testing, you can always remove the resources you have created by simply running Azure group delete. It deletes all the sample resources we have created for this demo. So with that, our session is very close to finish. You can always learn more about Java capabilities on Azure, or how to further extend our existing or new event-driven system solution by just going through these links. We have best practices, tutorials, and learning resources or learning paths you can take to become from the zero to hero. Also, we have some Azure migration programs. And we have also this guideline how you can adopt your system on Azure Cloud by for checking the adoption framework we have. So thank you for watching, and if you have any questions, I will be happy to answer regarding this session. And so thank you for joining me today.
Thank you, Bobur. Awesome. Great content again. And guys, here you have it, a different approach using real-time event-driven Java. Basically, it's a serverless approach, so you have this option as well. With that, we are moving to our final session where we'll be covering Azure Functions again, but using a Kafka extension. Ramaya, take it away.
I'm Ramya Oruganti. I'm currently working as a PM with Azure Functions. My focus areas are everything about enabling functions on Kubernetes. I work on triggers in the event streaming space, such as Kafka and Event Hub triggers, and I also work on triggers like SQL and RabbitMQ. And finally, I work on KDA, which helps with scaling of pods in Kubernetes based on the number of events needing to be processed. I will be presenting on Apache Kafka extension for Azure Functions, which was launched in GA during the Build conference in May 2022. I'm also going to be talking about the features that are available, popular customer scenarios that we came across, and finally show you a demo of a real-time application using the Kafka extension. So let's get started. Now let me talk about monolith and event-driven architectures. Monolith architectures are self-contained, where the program's components are tightly coupled. In such architectures, each component and its associated components must all be present for the code to be executed or compiled or for the software to run. Which also means that if one component is changed or updated, the other elements may also require rewriting and the whole application has to be recompiled and tested. Monolithic applications are single tiered, which means multiple components are combined into one large application. Consequently, they tend to have large code bases which can be cumbersome to manage over time. What happens if one of the request response chains link breaks? Requests that have been waiting for a response that do not get one. They either keep waiting or they run out of time. So the application as a whole has been disabled. In addition, as the number of services grow, so does the number of synchronous interactions between them. So in this case, a single system's outage has an impact on the availability of other systems. On the other hand, an event-driven architecture is a microservices-based architectural paradigm that structures an application as a collection of a small, loosely coupled services that operate together to achieve a common goal. Because they work independently, they can be added or removed or upgraded without interfering with other applications. On top of this, they allow for real-time microservices communication, enabling data to be consumed in the form of events before they're even requested. So decomposing monoliths to microservices is just a first step. So to be able to capture business moments in real time, you need something to tie these microservices together like a decentralized event-driven architecture. So shifting gears a bit, right? So serverless compute powering such architecture paradigms allow you to run code without provisioning or managing services. They also help create workload aware cluster scaling logic and also maintain event integrations or even manage runtimes. So, serverless applications such as Azure Functions are event driven compute services with several built in integrations. So, serverless stream processing is increasingly becoming a vital part of complex distributed systems to manage large amounts of data coming in as a continuous stream of events in real time. So, serverless event driven architecture is most employed in real time systems that require you to act and respond to data changes and events in real time. They are well suited for stream processing workloads, which are often event driven and have spiky or variable compute requirements. So, Azure Functions in combination with Kafka are powerful and easy to use services which enable you to build real time, event driven applications running on distributed systems. So, let me talk about some key features powering up the extension. So, as mentioned earlier, the Apache Kafka extension for Azure Functions was launched in GA during May 2022. This extension will help you to detect and respond to real time messages streaming into Kafka topics or write to a Kafka topic through the output binding. So you can just focus on Azure Functions logic without worrying about the event sourcing pipeline or maintaining infra to host the extension. Now, let me dig into the key features of the extension. So you can now create Azure Functions trigger or output binding code using Azure Functions Kafka extension. Both trigger and output binding can be written either in .NET, Java, Python, PowerShell, JavaScript, or TypeScript. As you can see, there are several languages that you can write the trigger or the output binding using the extension. So the header data can be passed onto the functions trigger that gets executed and can be further processed. And as per your requirements, the header data can flow to Kafka topic of your choice using the output binding. And we will see this in action shortly. This extension can also be used to deserialize Avro generic format data. And going forward, Java apps can also be created using Maven templates through core tools. Now let me talk about the new features which was launched like very recent. So Apache Kafka extension for Azure Functions support retry policy, which tells the runtime to rerun a failed execution until either successful completion occurs or the maximum number of retries is reached. Because error handling is very important, right, to avoid data loss or miss events, or also to monitor the health of your application. So retry policy is evaluated when a trigger function raises an uncaught exception. So as a best practice, you should catch all exceptions in your code and rethrow any errors that you want to result in a retry. So retry mechanisms are of two types, fixed delay and exponential backoff. So in fixed delay, a specific amount of time is allowed to elapse between each retry. And in exponential backoff, the first retry waits for a minimum delay, and on subsequent retries, time is added exponentially to the initial duration for each retry, and until the maximum delay is reached. So exponential backoff adds some small randomizations to delays to stagger retries in high throughput scenarios. And also do note that retry policy for Kafka extension is not supported for .NET in-proc and out-proc applications. This is only supported for languages such as Java, Node, PowerShell, and Python in both triggers and output bindings. So, like I said, this is recently launched. So hopefully, if you could point to the latest build, you'll get the benefits of this feature. We're happy to share that we've also enabled the auto offset reset setting as a configurable one, where you can configure either to earliest or latest. So setting this value to earliest configures the consumption of the messages from the earliest or the smallest offset or to the beginning of the topic partition, and setting the property to the latest configures the consumption of the messages from the latest or the largest offset or from the end of the topic partition. So this is supported for all Azure function supported languages and can be used for both triggers and output binding. Finally, the key support, right? So this was also recently launched and this was implemented in the extension, which enables customers to set or view the key in Kafka event messages coming into the Kafka trigger. And you can also set keys to the messages going on into the Kafka topics through the output binding. Therefore, key support was enabled in the extension to support both trigger and output bindings for all Azure function supported languages. So moving on, I would like to call out some interesting scenarios that we have come across. So here are a few scenarios from fintech and automobile segments where the Apache Kafka extension for Azure Functions is used either in an analytics and an insights platform, and these are powered by real-time streaming data services to enable end users to make decisions. So the Kafka trigger function app feeds the event into another Kafka topic, which gets processed for 4 more times with transformational and quality checks at each stage. So the final event lands in a NoSQL Cosmos DB store for analytics. We've also come across an investment app to suggest customers on stocks assets. So the Kafka trigger and output binding function app acts as a messenger between Kafka brokers and Cosmos DB. So as you can see, function apps using the Kafka extension is helping to connect the real-time streaming systems to analytical systems for transformations, quality checks, and driving real-time insights. All this is happening in an event-driven and serverless mode powered by Azure Functions. Let me talk about Azure Functions and Java investments that we're currently working on. And this is predominantly to improve the experience for customers while building Azure Function apps in Java. So if you haven't heard, we recently announced the public preview of Durable Functions for Java. As you all know, Durable Functions is an extension for Azure Functions that lets you write stateful functions in a serverless environment. So this extension essentially manages state or checkpoints. On the other hand, Java 17 support will be launched in public preview soon, and we'll also be launching a second version of public preview for distributed tracing support in Java. This will enable users to opt in or opt out of distributed tracing. And finally, we are also expecting to launch durable function support for Java as well. It's time to see things in action. Let's take a look at the scenario, which is a real-time wallet transaction processing built using Azure Functions Kafka Trigger extension. And these Kafka brokers are hosted on Confluent Cloud. In this demo, we will see how several events are captured by Function app and how Kafka topics are populated with events which are extracted from Kafka headers and deserialized messages. So the wallet producer generates wallet events in Avro generic format, and Function apps gets executed whenever a wallet event is produced. These event messages are further processed to determine the mode of channel, like either an email or SMS or in-app to notify the messages. So these messages are sent to the respective Kafka topics which are collecting emails or SMSs. Finally, as a message lands into the respective channel topics, the respective function apps gets triggered to send the notification messages either through the identified channel. That is, all email messages will be email, SMSs will be sent through SMS, or in-app marked messages will be available in the app. Now let's look in the detailed workflow of this scenario. So the function apps are hosted on Azure Functions mapped to an Azure resource group, and these function apps are integrated to the Confluent Cloud instance hosting the Kafka brokers and topics. So Confluent Cloud instance was created using the Confluent Cloud for Azure Marketplace offering, which is mapped to the same Azure resource group. As you can see, the wallet producer is a local Java code which helps to produce wallet events into the wallet event Kafka topic hosted on Confluent Cloud. So these events are currently produced in an Avro generic format into the Kafka topic wallet event. So as events land in wallet event Kafka topic, a function app hosted on Azure Function Service is called, and this function app is essentially named as wallet listener, and this triggers in. So this function app uses the Apache Kafka extension for Azure Functions, and it also uses confluent.schema-registry.service.avro package, which is provided by default in the extension to perform the conversion, right? That is to deserialize the Avro messages into strings. So another thing to note is that this function app, the wallet listener, initiates headers which carries a mode of communication, whether it's email based or SMS or an app. So the deserialized data and headers are sent as messages to notification event topic using the function's output binding, which allows an Azure function app to write messages to Kafka topic. So then events landing into notification event topic will in turn trigger the function app called notification listener. So based on the header data per record, the notification listener function app uses the output binding and populates the corresponding Kafka topics with messages. For example, record maps with emails are sent to notification event email topic, or records map to with SMS are sent to notification event SMS topic. Finally, as messages land in email topic, email specific function app gets executed, which will help with emailing the respective email message. Now let's look into the demo of the wallet transaction processing. So let's see things in action before we execute the Azure Function APIs. So let me walk you through the prerequisites for executing this real-time sample scenario. As a first step, create the Confluent Cloud instance. For this, go to the Marketplace offering and search for Apache Kafka on Confluent Cloud and look for the SaaS offering here. So once you go to the SaaS offering, click on subscribe to create the Confluent Cloud instance. So after successful creation of the Confluent Cloud resource, an Azure resource is essentially created, which is mapped to a resource group and a Azure region. And more importantly, an SSO URL is being generated. So this SSO URL takes you to the Confluent Cloud UI dashboard. So using this dashboard, we can create clusters, topics, and so on and so forth. So once you land into the Confluent Cloud UI portal, create a cluster. After creating the cluster, the second step is to create the schema registry. And before we move on to the schema registry, as a best practice, make sure your cluster and Azure functions are deployed to a same region to avoid any latency issues. So now let's proceed to creating the schema registry. So schema registry helps with managing the schemas in Confluent Cloud. So you can create a schema registry for this cluster, and each cluster has a unique schema registry endpoint. And here also you can choose to deploy on the same region as the cluster. And this will essentially create a API endpoint and a secret. So after creation of schema registry, we can proceed to creation of topics. So we need 5 topics for this scenario, and you can create the topics using the default topic settings. And here is a view once the topics are created. Now, so as a wallet event takes in the Avro records, we need to set schema type for this specific topic as Avro. So just select the topic and then go to schema and click on add schema. So here we'll have to click the format type as Avro and then paste the schema that is available in the sample, such as wallet.json content, and copy this schema and paste it on the schema window and click on save. Right, once you on successful saving of this, schema gets created and it gets mapped to that specific topic. And here is a view of the topic once the schema is mapped. And then you have to see a green tick um, indicating that the schema is successfully created and registered for this topic. Right. Now, before we move on to the code part, also make sure that the cluster has a API key and a secret. So these endpoints are needed to configure in the code. Now let's switch to the Visual Studio Code editor. So here first clone the Git repo and make sure you update the local settings.json with the Kafka broker, URL, API keys, secrets, and topics that you have configured in the previous step. And also make sure to update the producer config properties with Bootstrap servers and schema registry URL and SAS jazz config. And then go to the pom.xml with the and update the API endpoint of the schema registry. So this will be these values will be leveraged by the wallet producer to generate wallet events into the Kafka topic. So now let's create the Azure Functions app. So go to the Azure portal. You may create from the portal or you can create from CLI as well. So the next step is to create the Azure Function app. And make sure you create the function app in the same resource group as Confluent Cloud instance and same region as a Kafka broker. The other important thing to note is that make sure that you set up the runtime driven scaling to on. So you can find out if the runtime driven scaling is on or off by going to the configuration tab and go to runtime function runtime settings and make sure that the runtime scale monitoring is on. This will enable scaling of the function app deployed to the triggers, right, that are deployed to the function app. So once the function app is created, now we have to make sure our functions are deployed. That is, the trigger apps are deployed. So you can do this using CLI or Maven deploy. Right. So here is the view of all the trigger apps and the function apps using the Kafka extension being deployed to this specific Azure function app. So here is a view. So now let's see the event messages coming into the Kafka topics. For that, we'll switch to the Visual Studio Code. Now let's execute the producer code to populate the events. So go to VS Code and run the Java code, which essentially produces events to the wallet event node topic. So as you can see, the wallet event started to produce. Now let's go to the wallet event topic. As you can see, uh, the Kafka topic called wallet event is populated with the events produced by the producer Java code, and the header data is empty currently, and the value column has uh, Avro generic format data. So now let's go to the notification event topic. So with this, the wallet event listener Azure function gets triggered and it takes the messages from the wallet event topic, deserializes it, and adds a header data. So the result of that is populated into the notification event topic. So in this, if you can see, the header data is now initiated uh, with the communication mode type, and the Avro generic data is deserialized and populated into various columns. So this processing is happening through the Kafka extension code. And finally, once the notification event topic is populated with messages, the notification listener Azure function is triggered. which will in turn populate the data into the respective notification event email topic or SMS topic or in-app topic, right? So for example, if we observe the notification event email topic, the email specific messages are routed into this Kafka topic by the notification listener. And as you can see, the headers and the respective deserialized data continues to get populated into this topic as well. I hope this session was useful and helpful. So let's get into the Q&A segment. So please drop in your questions in the chat window and we're happy to answer them.
Thank you. And that was our last session for this event. Really appreciate you guys joining the event. We'll stick around for any questions that you might have and try to answer them. Also, check out the additional content that we have prepared for you. Last but not least, this session will be made available for on-demand view. So anytime you want to go back and review some of the content, this option will be available. Thank you once again and see you in the next one.